The 88mm German gun and shells with explosive fillers turned tanks into steel crematoriums. They instantly proved why crew survival became the war's primary crisis. What happens when a shell with an explosive filler punches through steel armor? Standard Allied rounds were solid shot. They relied on kinetic energy alone. The Germans chose a different path. Their armor-piercing shells carried a hidden cavity filled with PETN, or RDX. A specialized fuse sat at the base. Impact. The nose of the shell bites into the Sherman's frontal plate. It grinds through 3 inches of steel in a spray of white-hot sparks. Then, the breakthrough. The shell enters the pressurized cabin. Between penetration and detonation, only milliseconds pass. Inside the hull, the delay fuse reaches its limit. The shell doesn't just pass through, it vanishes in a localized sun. The explosion acts like a heavy fragmentation grenade triggered in a locked closet. Shrapnel ricochets off the internal bulkheads. It shreds hydraulic lines. It finds the stowed main gun rounds. The 88mm Flak 36 weighed over 9 kilograms. It left the muzzle at 820 meters per second. At that speed, the energy alone was lethal. The internal blast made it absolute. Earlier in the war, the 50mm Pak 38 could handle a Sherman at close range. It was a stopgap. The Germans quickly upscaled to the Panzer IV's long 75mm gun. This was the Pak 40. The 88mm gun was a distant threat, but the city streets held a different kind of terror. Hidden in the ruins, German infantry waited with the Panzerfaust and the Panzerschreck. These were not just rockets, they were portable executioners. Inside the warhead sat a shaped charge. On impact, physics turned into a nightmare. A high-velocity jet of molten metal hissed through the steel armor like a needle through wax. Droplets of white-hot copper sprayed the interior. They ignited the fuel lines and cooked the ammunition racks in milliseconds. One hit from a Panzerfaust killed more crew members than a direct strike from a heavy anti-tank gun. Crews grew desperate. They strapped logs, sandbags, and thick slabs of concrete to the hulls. They hoped to detonate the charge before it touched the main plate. It was a placebo. The molten jet burned through the makeshift layers without losing a fraction of its lethality. In the Pacific, the threat changed shape. Japanese soldiers buried standard anti-tank mines, but they added a lethal multiplier. At Okinawa, a 30-ton Sherman struck a mine rigged to a 500-pound aircraft bomb. The blast wave defied gravity. It lifted 30 tons of American steel into the air and flipped the tank like a toy. The footage shows a single crewman standing by the overturned wreck. He watches the hull. He waits for the others to crawl out. No one moves as the smoke begins to billow from the treads. He was the only one left. To meet that molten copper on the sands of Okinawa, the American machine had to emerge from a state of total technological coma. The year was 1939. Europe watched as German steel crossed the Polish border. In Washington, the situation looked different. The United States Army ranked 17th in the world by size. Behind Portugal, behind Romania. What did the American military have to counter German tank wedges in 1939? The answer was 400 light machines. They weren't even called tanks. The cavalry labeled them combat cars. Most were M2 series models. They were tall, thin-skinned, and vulnerable. While the Wehrmacht practiced combined arms maneuvers, American armor development lay in hibernation. The contrast was lethal. Germany built thousands of panzers for the Blitzkrieg. America had a handful of scout cars. The gap wasn't just in numbers, it was in doctrine. By the time the United States prepared to enter the conflict, the war had already reached North Africa. Engineers scrambled. They lacked the technology to mount a heavy cannon in a fully rotating turret. The result was the M3 Lee. It was a stopgap, a strange, towering silhouette. Designers bolted a 75mm gun into a fixed casemate on the right side of the hull. On top, they placed a turret with an obsolete 37mm pop gun. It was a compromise made of desperation. The Pentagon prioritized time over perfection. They needed hulls on the ground to stall the Nazi advance. They loaded the M3 Lee onto freighters and sent the first shipments to North Africa. The clumsy M3 Lee was a stopgap. In 1941, the U.S. Army needed a solution, not a compromise. They took the reliable chassis and drivetrain of the Lee and built a new machine, the M4 Sherman. The change wasn't just about the silhouette, it was about survival. Older tanks relied on riveted armor. When a shell struck a rivet, even without penetrating, the metal bolt turned into a projectile. It sheared off and screamed through the interior at hypersonic speeds. It was a localized hurricane of jagged steel. To fix this, engineers pivoted to an all-welded hull. No bolts, no internal shrapnel, just solid plates of steel fused together to keep the crew in one piece. By 1941 standards, the Sherman looked formidable. It carried a 75mm gun. The weapon excelled at firing high-explosive shells to clear out bunkers and infantry. High command expected it to handle enemy armor just as easily. But the desert was waiting. Thousands of miles away, General Rommel had already turned the sands of North Africa into a graveyard. He didn't just have tanks, he had the 88. The Germans took their massive anti-aircraft guns, leveled the barrels, and waited for the American steel to appear on the horizon. Rommel's troops were equipped with these specialized 88mm anti-aircraft guns. British crews under Montgomery were the first to test American welds against Rommel's steel. It was late 1942. 250 brand new Shermans arrived in Egypt, freshly coated in desert camouflage. These machines accounted for nearly 20% of all Allied armor at the Second Battle of El Alamein. To the British, the tank felt like a gift from another world. Why did British tankers in 1942 consider it a miracle to simply shut off an engine at night? Because their own Crusaders and cruisers rarely started again the next morning. The Sherman did. The crews praised its reliability. They loved the power of the 75mm gun. It was a massive leap over the old 40mm pieces on their light tanks. For a brief moment, the American cannon could punch through Panzer IIIs and IVs with ease. At least, before the Germans thickened their frontal plates. The British demanded more. They saw a winner. But the honeymoon was short. The tanks were better protected than their predecessors, yet far from invincible. A single hit often turned the hull into a furnace. The Sherman was already earning its reputation as a Ronson lighter, guaranteed the light the first time, every time. It could shrug off the old, small-caliber anti-tank rounds, but it stood no chance against the heavy German batteries. Specifically, the armor failed against anything larger than the older 50mm guns. British veterans at El Alamein had already learned the desert's lethal grammar. The Americans arrived in late 1942 as students. They brought a mix of the tall, awkward M3 Lees and the brand new M4 Shermans. They lacked experience. They lacked intuition. They were about to pay for their education in blood. The test came at Kasserine Pass. It was the first major collision between United States forces and the German war machine. The Americans moved in green, tight formations. They trusted their new steel too much. German anti-tank guns waited in silence. Then the desert erupted. The noise was a chaotic mechanical scream. Solid shots slammed into fresh olive-drab hulls. High-velocity rounds from Panzers tore through the American lines, outmaneuvering the static Shermans. Formations broke. The valley became a graveyard of burning engines and shattered tracks. It was a total tactical collapse. The survivors retreated, leaving behind the husks of their machines. They had survived the massacre and began to adapt. Survivors of the Kasserine Pass learned a brutal lesson. The greatest threat came not just from German anti-tank guns, but from the engineers who designed the hatches. 3 men occupied the turret. One narrow two-piece hatch served them all. Inside, the space was a geometric trap. To enter, the loader climbed in first, squeezing behind the heavy gun breech. The gunner followed. The commander sat last. In a crisis, this sequence had to reverse perfectly. What was the chance of survival when 3 men shared a single exit? Very low. When a shell pierced the hull, the cabin became an oven. choking, oily black smoke filled the lungs in seconds. The temperature spiked toward 1,000 degrees. A tanker had less than 10 seconds to escape before the toxic gases or the flash fire triggered fatal trauma. Imagine the reality. A shell kills the commander and gunner instantly. Their bodies slump, dead weight blocking the only way out. The loader is trapped beneath the breach. In 1942 and 1943, this was a common death sentence. One veteran recalled trying to shove the corpses of his friends aside while the air turned into fire. He couldn't move them. He only survived because the turret had stopped at an angle, allowing him to crawl through the hull and out the driver's open hatch. The Army realized the flaw too late. By 1944, they introduced larger, oval hatches. They added springs to counter the heavy steel. Most importantly, the loader finally received his own dedicated exit. The Sherman carried CO2 extinguishers and engine suppression systems. They were useless. When sparks showered the interior, the manual was forgotten. The only tactic was flight. Crews began drilling in total darkness. They learned every bolt and lever by touch. They practiced the exit until their movements became an automatic reflex. By late 1944, a trained crew could clear the turret in 5 seconds. The survival of the crew didn't depend on the engine. It depended on the cargo. By 1942, the M4 had earned a lethal reputation as the Tommy Cooker. Burning tanks were a systemic failure. The statistics were a death sentence. 80% of hit Shermans burst into flames. After the introduction of wet stowage, that number plummeted to 15%. A single shell starts the clock. The projectile pierces the side armor. It hits the sponson, the internal shelf above the tracks. Inside, 97 brass casings sit in open racks. Sometimes, crews cram in 140 shells, desperate for extra firepower. The impact shatters the brass. Cordite spills out. A single spark triggers a chain reaction. What happens next is high-pressure physics. The propellant in 140 shells ignites simultaneously. The resulting blast possesses enough raw energy to rip a 15-ton turret clean off its ring. Crews evacuated in a blind panic because the Sherman became a furnace in seconds. The culprit was never the gasoline engine. It was the ammunition stored at chest height. Engineers scrambled for a fix. They designed wet racks, double-walled steel containers. Between the walls sat a sweet-smelling mixture of water and glycol. When a fragment pierced the casing, the pressurized liquid flooded the shells. It didn't always stop the fire. It bought time. 10 seconds of damp air meant the difference between a clean exit and a blackened hull. The Army eventually realized the liquid was only half the cure. The real salvation lay in geometry. They tore the racks out of the vulnerable sponsons and moved the entire combat load to the floor of the tank. The nickname Tommy Cooker suggested a death trap. 140 shells packed into sponsons created a powder keg. But the cold data of 1944 shatters the myth. How many tankers actually died inside a knocked-out Sherman? The United States Army analyzed combat losses between 1944 and 1945. The result was a statistical paradox. Despite the firestorms and thin armor, the average death toll was 1 man per destroyed tank. Geometry saved lives. The Sherman's combat compartment was spacious. Engineers installed spring-loaded hatches that flew open at a touch. In a burning wreck, seconds determined who lived. A crew of 5 had room to move. The contrast with Allied hardware was grim. Soviet records for the T-34 showed a different reality. 2 tankers died for every disabled vehicle. The Soviet machine carried 4 crew members. The American tank carried 5. Yet the T-34 suffered double the fatality rate. The single casualty from the 1945 report left behind a problem for the burial teams. A hit tank was not just a wreck, it was a crime scene. Graves registration units arrived first. These men stepped into a space where steel had met flesh at 2,000 miles per hour. What remained inside? If the ammunition ignited, the crew became charcoal. If the tank didn't burn, the interior was coated in a red, jelly-like film. The logic of the industrial war demanded a fast turnaround. The process was mechanical. Technicians opened the escape hatch at the bottom of the hull. They inserted high-pressure hoses. They flushed the remains of the previous crew onto the dirt through the floor. Once the metal was clear of organic matter, the sensory masking began. The air filled with the sharp chemical sting of fresh white paint. Workers sprayed the interior until the bloodstains and scorch marks vanished under a sterile coat. They welded the penetration holes shut. The patch was ground smooth. The tank looked new. This recovery system worked with cold efficiency. More than 40% of knocked-out Shermans returned to the front within weeks. The U.S. Army treated tanks like replaceable components in a massive machine. The crews followed the same logic. Survivors from different destroyed platoons met at assembly points. They formed ad hoc teams. These men climbed into refurbished hulls that still smelled of wet paint and ozone. Some soldiers lost 3 different tanks in a single week. They wiped the controls, checked the oil, and drove back toward the tree line. The new crew readied the gun for the next engagement.